Okay, good evening, welcome to
AwesomeMath167.
AwesomeMath167. So, just trying to do our videos tonight since we got a busy morning tomorrow morning. So we learned about the Pythagorean theorem this morning. And I'm going to talk to you about the Pythagorean theorem in higher dimensions. We think of it on the plane, but it tells us some kind of neat stuff about cubes in every dimension. So first we'll start out with a square, which is a two-dimensional cube, right? How can we use, let's pretend the side length of our square is 1. How can we use the Pythagorean theorem to find the length of this long diagonal of the cube?
Well, we can do a squared plus b squared plus c squared. So these are all 1. So it's a squared plus b squared plus c squared. So it's 1 plus 1 is b squared plus 1 squared. That's 2.
Okay.
So that means this side is square root of 2.
Square root of 2. Wow, so the long diagonal of a cube, of a square,
The square root of 2.
has length equal to the square root of 2. Now, I made a three-dimensional cube out of Zone tool. And I made the long diagonal there. How can we use the Pythagorean theorem to find the length of this long diagonal of the cube? What do you think?
Well, we sort of divided it up into 2 pyramid shapes.
Sort of.
Maybe we could do these 3 sides combined. Like maybe this side plus this side plus this side.
Interesting.
And that would be 1 squared plus 1 squared plus 1 squared.
And what would that give us?
That would give us 3, so then this side would be square root of 3.
So maybe this side's the square root of 3. And that's an interesting idea, but we need a triangle. A right triangle to apply the Pythagorean theorem. So do you see a triangle that has
Well, you
this?
could make a square root of 2 line here.
Oh! And I would have done it if we had greens, but we don't have greens with us down here. So we do have a triangle
So we have a 1.
where this previous, ooh, don't use the purple marker on the board. This previous diagonal from the lower dimension was exactly part of our triangle. So we had a triangle that was 1 high, square root of 2 long, and that made this how long?
Square root of 3.
Square root of 3. So that's in a three-dimensional cube.
Cool.
What should we look at next?
The 4-dimensional one.
What does that look like?
Well, that's a hypercube.
Yeah, can you picture it?
Sort of.
Okay. It's hard to picture, but it's good to think about. What do you think the length of the long diagonal in a hypercube is going to be? What kind of triangle are we going to have?
We're going to have a hyper triangle.
Well,
Hyper triangle.
what are the lengths of the triangle?
Well,
Do you think what do you think they're going to be when we draw the long diagonal of a hypercube?
Maybe then maybe we can use the square root of 3 again.
Ah.
So
So maybe it'll be like what we just saw. The lower long diagonal is one part of our triangle, and then it goes up 1.
square root of 3 this time. So that means this would be square root of 4, which is 2.
Look at that.
So we have a 1 square root of 3, 2 triangle.
Yeah, in a 4-dimensional cube, the long diagonal has length 2. 2. What do you think it is in a 5-dimensional
I
cube?
think it's square root of 5.
Whoa. What do you think it is in a 10-dimensional cube?
I think it's square root of 10.
Whoa. Can you picture a 10-dimensional cube?
Not really.
Not really, but the Pythagorean theorem lets us see how long the diagonals are.
Yeah.
What's the next one above the 4th dimension where that long diagonal is going to be an integer?
Well, that'll be a 9. It's square root of 9.
9 dimensions. And do you notice anything that's surprising about the length of these long diagonals?
Well, the length of the long diagonal, it's square root of the dimension you're in.
Square root of the dimension, which means it keeps getting larger and larger. So you wouldn't think going across a cube in higher dimensions would get longer and longer from one end to the other end,
Not really.
but it does.
Cool.
It gets super long, actually.
Yeah. And then this side gets longer too.
That's right. That's right. All the edges of the cube are 1,
Yeah.
but the diagonals that go
They
all
keep-
over the place keep getting
larger.
longer and longer and longer.
Cool.
Pretty surprising.
Yeah.
All right. Good work. So the Pythagorean theorem lets us understand cubes in any dimension.
Cool.
Fun.
Yeah.